Hello, everyone. This is Dr. Wen. Here is the question. If A1, A2 till AN are N different positive integers. So here, at least we have 2 here. The sum of this less than or equal to 2. Can you prove this? First of all, we assume A1 is bigger than or equal to 1, less than or equal to 2, less than N. We can rearrange those N numbers in the ascending order because they are different. So we always can assume this way. Less than, not equal. So here, this is at least 1. The smallest should be 1. This implies this one. Can you see that? The first one should be bigger than or equal to 1 because they are positive integers. Right? The second one is different from first one. It's bigger than the second one should be bigger than or equal to 2. And third one should be bigger than or equal to 3. The last one, AN, should be bigger than or equal to N. Can you see this? We flip both numerator and denominator at the same time from those inequality first, then square both sides we have here. Consider the reciprocal. Look at the last one. AN bigger than or equal to N. If we flip both numerator and denominator, we can see 1 over AN. The right-hand side should be 1 over N. If you interchange it, numerator and denominator at the same time, you need to change the inequality direction, change it to less than or equal. So we have 1 over AN less than or equal to 1 over N. Then both sides, we take the square. You have 1 over AN to the power 2 over less than or equal to 1 over N squared. Similarly, for each inequality, we have this here. So now, what's the question? The question is, we want to derive this inequality. So the left-hand side is here, And the first item, less than 1 or equal to 1. Second items, less than or equal to 1 over 2 squared. The third one, the last one. So this is the current result here. Now, is this true? The first term is here. The second term, less than this. The third term, less than or equal to this. And the last term, less than or equal to this. Is that true? If it is true, this is true. Okay, this is the important part because we are using a typical trick to solve this kind of problem. So just to look at last one, 1 over N squared. N squared means N times N. What's the difference here? And this here, we change 1N to N minus 1. That means reduce the denominator because N is bigger than N minus 1. So the denominator reduced. So the whole number is increased. So this number is bigger than this number, right? So this is bigger than, right? From this side, you can read it this way. This number is bigger than this. So this number is less than this number. So this is the general term. So look at this one. The second term, 1 over 2 squared. This is 2 times 2. We change 2 to 1. So here's 1 times 2. Denominator becomes smaller. So this number is bigger. So this number is less than this number. Similarly here, That's 3 times 3. 1 over 3 times 3 less than 1 over 2 times 3, because this denominator is smaller than this one. So this number should be bigger than this. So this number should be less than this. Now here, look at each items. So this term, we can rewrite it as 1 over 1 minus 1 over 2. We can check it. What's the common denominator? That's 2. So the numerator, that's 2 minus 1. So 2 minus 1 is 1. So look at here. What's the common denominator? That's 2 times 3. 2 times 3. That's the numerator. That's 3 minus 2. That's 1. Similarly here, common denominator is n times n minus 1 here. And the numerator should be n, then minus of n minus 1. So n cancel, minus 1 should be plus 1. So here, this is equal to this. Let's mark it. Now look at it. So we have negative 1/2 here, and here's positive 1/2, cancel each other. Negative 1/3, positive 1/3, cancel each other. Negative 1/4, you have negative 1/4 here. You have negative 1 over n minus 1 here, and positive 1 over n minus 1. So what's left? So here, what's left? We have 1 here, and here I have 1 over 1 here, another one. And you have the last term, that's 1 over n, here negative, that's minus. 1 plus 1 is 2 minus 1 over n, because n is a positive integer. So this number is less than 2. We have done the proof, because here you can see this is less than or equal, less than equal, equal, less than equal. So imply this is less than 2. That's all. Thanks for watching, and see you next time.